And now we have Algebra 2, Lesson 10.5. This one is called the law of sines, and 10.6 is called the law of cosines. The first and most important thing I want you to know is lessons 10.1 through 10.4 had to do with right triangle trigonometry. So when we use sine, cosine, tangent of an angle equals the ratio, that is for right triangle trig. The functions sine, cosine, and tangent are also useful when we don't have a right triangle. So that's the big difference between lesson 10.5, 10.6, and what we've already done is we're going to switch to non-right triangle trigonometry. So to begin with, we're going to talk about area and then the law of sines. And then the next lesson has another different area formula and the law of cosines. So here we go. If we want to find the area of a non-right triangle, we can. So with a right triangle, you can call one side the base and one side the height, and the area is 1/2 base times height. But if you don't have a right angle, sometimes finding the height is a little more difficult. Like we have in this drawing here, we have a base, and my height is not one of the sides, so I don't know how high it is. So here we have a sail. The sailmaker needs to know how much fabric to use, and the area of a normal triangle is 1/2 base times height. So how would I find this height? Well, in this big triangle, we can see a right triangle on the inside of it. So I'm basically talking about just the left-hand side. Excuse my not straight lines here. And we have a right triangle there. So we can use sine to find out what h is. So for the 73, we have opposite and hypotenuse. So sine of 73 degrees is opposite over hypotenuse. And so I have this function, and I could solve it for h by just multiplying the 2.96 meters over here. And then I have a value for h. So here's my h. Now where did h come from? It came from side C and the sine of angle A. So if I wanted to kind of generalize this is side C times the sine of A, and that would be my height, and my base is B. So my formula for area, I've got 1/2. My base is still B, and instead of H here, I would put C sine of A. So this is my new area formula, and this is on the next page written a little nicer, but this is kind of where it comes from. So here that's it, building it. Let me turn one more page here. Okay, so we have this formula that I just created with you. Area is 1/2 B times C times the sine of A. Now that means I have angle A, and I have side B, and I have side C. So if I know these three pieces, I can find the area. Now I can name an angle whatever I want. So I could know angle A, or what if I knew angle B? Well, if I knew angle B, then I would use the two sides next to it. So I kind of think about this as like side, angle, side. I need to have a side, an angle, and a side to find the area of this triangle. I don't memorize all three of these. I just name whichever angle I know is going to be angle A, and I have to know the two sides next to it, and it's 1/2 side times angle A. They have to be next to it. So you can look at those other formulas, but they're all just rotating the triangle and looking at it from a different angle. So here, they didn't label any side at all. I would call this side A because it's the angle that I know. And then the other two are B and C, and it doesn't really matter which one's which. So if all I need to do is find the area of this, my formula is 1/2 times B times C times sine of A. So for this problem, B and C are 3 and 5, so it doesn't matter which one I put first. 3 times 5 times the sine of my angle, 40 degrees. And this is when you need to make sure your calculator is in degree mode, because that's a 40-degree sine. So after checking that, we can type in 1/2 times 3 times 5 times sine of 40. This is Not going to be a whole number. It says round to the nearest tenth. So the area is 4.8. I should probably put units. So up here, this has units of meters. This is area, so this is meters squared, because it's 3 meters times 5 meters times an angle. There we go. All right, that's it. So the area formula is pretty simple once you know what it is. Now we're going to do something called the law of sines. The law of sines can help us find any missing pieces so that we can solve or find all of the missing pieces in any triangle. It does not have to be a right triangle anymore. It can be, technically, but usually these problems will not be a right triangle anymore. Law of sines is pretty simple. It's just the sine of the angle over its opposite side equals the sine of b over little b equals sine of c over little c. Capital C is your angle, lowercase is your side every time. So basically they're just saying that these are proportional. The sine of this angle to this side, the sine of the angle to the side, the sine of the angle to the side. So you just match up the opposite pieces. So let's do one where we have to set this up. There's a couple places where you have to be a little bit careful. You can solve this triangle if you know 2 angle measures and any side, because if I know this angle and this angle, guess what? You should be able to find this angle, right? Because how many degrees are in a triangle? 180. So if I know 2 of the angles, I can definitely find the third one. And then if I have some side, as long as I have one side, I have one proportion. Like I could do sine of this angle over this equals sine of this angle, and I only have one missing piece. So basically you have to have 3 of the 4 numbers in a proportion in order to solve it. So that's angle, side, angles, what I started with. You could have angle, angle, side, because you can always find the third angle. You can also solve these if you have 2 side length and an angle that is not in between them. So here's a rough picture of that. If I have 2 side lengths and an angle that is not in between them, then I can solve this because I don't know angle A, but let's say I have a number here. I have a number over a number equals an unknown over a number, so I can solve that proportion. If I had the angle in between here, if I had angle C and A and B, then in my proportion, I wouldn't have any 3 of the 4 parts. So what I mean by that is you have to have the sine of an angle. You have to have, when you set up a proportion here, you have to have 3 of these 4 numbers or you can't solve it. So let's do it for this problem. We've got 2 angles and a side, and it says solve. When it says solve, I need to find all the missing pieces. So I'm just going to list over here. What are all the things I don't know? I know D, I know F, I need angle E, and then I need little e and little d. When I've got 3 of the pieces, I need 6 pieces in order to solve a triangle, so I need to find these other 3. Now angle E is going to be the easiest thing to do, so I'm going to do that first. 180 minus 33 minus 28 is 119. So I have a 119 degree angle up here, and I like to label it on my picture so I can continue solving. So that didn't use any laws at all. That's just, well, it is a theorem in geometry that the angles in a triangle add up to 180. Now I'm going to use the law of sines to find these missing sides. It's not a right triangle, so I can't use Pythagorean theorem, and I can't use sine, cosine, tangent as they normally are. I can use the law of sines. In order to use the law of sines, you want to have an angle and its opposite. These other ones, I don't know their opposites, so I'm going to start with F. Sine of 28 over 15. That's a proportion where I know both of the numbers, ratio. And then I'm going to pick either one of these other ones. Let's go ahead and do D. So sine of 33 over little d. And I set up, this is my law of sines. Sine of the angle over the side, sine of the angle over the side. The only thing I don't know here is D. This is a proportion. So all I need to do now is cross multiply and divide. So if I was doing this out, I would have 15 times the sine of 33 equals d times the sine of 28. 28, and I'll just divide by sine of 28. And then I'll have d. So in my calculator, 15 times the sine of 33, and I like to hit enter or close that parenthesis, and then divide by sine of 28. My answer for D is 17.4. I'm going to put this over here so that I have my final answer all clean in one spot. Now, in order to find the other missing point, angle, side, whatever this is, I cannot use Pythagorean theorem because I don't have a right triangle. So I have to basically just do the same setup again. I already have sine 28 over 15. That's given in the problem. So this time I'm going to use the 119 degrees that I don't know there over E, cross multiply, divide, and I will have my answer. So in my calculator, I'm going to do 15 times sine of 119 divided by sine of 28. Answer. Multiply these, divide by that one, and you get 27.9. If there are units, you would put units here, but we don't have any on this problem. Okay, let's look what can happen here. When you use the law of sines, for which you know the side-side angle, we can have a problem. So these are the ones where I say you got to be careful. You're going to be checking this. So if you have side-side angle, let me show you. Side-side angle. Side-side angle. Technically, depending on what the angles are, I could have two different triangles. So you have this triangle that I drew here with these sides are fixed length and this angle is a fixed length. Okay, I'm going to draw another triangle with the same side length and the same angle here and the same length. This length, let's just draw it right here. It's still the same length S, but I have a completely different triangle. This smaller one here and this bigger one. So with angle side-side angle, I don't know if you remember from geometry, but that's the nasty one that does not work because, well, when you write it backwards, it spells a bad word, but also because it just breaks the rules of congruence. So we are not guaranteed to have two congruent triangles if we set up angle side-side. So when we go to solve these, we have two different triangles that we might be solving for. So that's what the video of part 2 is going to be about. So come back and watch 10-5 part 2.